Hi guys, welcome to my channel. Today I'll be recording a video on how can we fix the skewed joints in PySpark. So before I start with the code, I would like you to take through what I actually understand of. So today I'll be focusing on what are skewed joints and how do they affect the performance of your data pipelines. Since my channel is focused on data engineering and designing data pipelines and optimizing them, so I just want to use this time to focus on the most important topic, and also it is very critical from data pipeline performance. The reason I am using ChatGPT because I think you need a AI tool to enable or improve your understanding of topics instead of going through multiple web pages. And it also defines the things which you should focus on. So, most of the time, what happens is when you have a lot of records and you are doing a join, there might be one or two hotkeys which cause the skewed join. So, first of all, we would be this is a sample notebook, but I would still explain in detail where does the join happen, skewed join happen, how does these joins work, and what actually delays the performance or reduce the performance of the pipeline. So by default you shuffle the partitions 200. For your information, I'm using Databricks free edition. Everyone can, it's available to everyone. I'll just post a link in my video wherein you can create an account for yourself for Databricks free edition, and it will help you to understand Databricks like in depth instead of just going through YouTube videos wherein you see a lot of stuff but you don't actually do it. So I would prefer you to create an account for Databricks free edition and then go from there, right? So this is a notebook which I have created, and herein what I'm doing is I'm creating two data frames, left and right, and I have created columns like AAPL, BTC, and ID, and there is a column again, a trade value, which is based on a random value which I have generated using the random functions. So this code can also be in Spark SQL if you understand the basic concept, the fundamentals. It won't cause you because it's just the syntax. And if you understand that, the more critical part is how do joins work. What is the count of records, on which keys we are joining, the two data frames or two tables or two views, whatever like you think of. So without any delay, let's get started. So what are hotkeys, right? Like it will take you a bit of time to even understand hotkeys because the terms are sometimes a bit specific, and so a single hotkey, for example, let's start with this example. So here what I'm doing is I'm creating a left data frame. I have a ticker column. I'm saying whenever the ID is between this, you make this a huge skew. So I'm putting actually a lot of records on this AAPL column, right? So let's run this first and I'll show you. So yeah, and now we can see the data frame, right? What you can do is you can leftdf dot show. You can see a bit of records, so it's easier to even understand how does the data frame look like. You can also see the schema of the data frame. So it doesn't have any I don't know it. So you can see that there is a column ticker, right, and it has AAPL and there is a column trade value, and there is a column event type, right? Since you have put almost 200,000 records on key AAPL, right? And then there are 500 on BTC, so this can also be checked. So what you can do is how can you check it, right? So there are so many records on AAPL, right? So I'm just checking how many records. I just checked 10,000 rows, right? So actually there is let's see, let's ask Genie. I want to see the number of records wherein ticker equals group by ticker, right? Group by ticker, right? Ticker, right? Yeah. Want to see the number of record group by ticker? So it will show you count asterisk. So yeah. So what I'm doing is I'm grouping by ticker, and I'm just counting the number of records. For example, if there is A period, it will count the number of records. And let's run this. What is join df? I don't want to go to the join df. So you have to make sure that so this is there. Let's run this. You'll be able to see that, we can see there are how many records? Almost 1.2 million records for A, PL, BTC, and respectively for others there are very few records, right? So to understand the skewed performance in a pipeline, you have to see so these are the count by ticker column, right? So let's go on to the other data frame, which is right data frame, wherein also I'm using this ticker column, and I also have a reference price, and yeah, let's see this one, and now it has run. Let's use the same for your right df, right? So instead of left, so basically you see the count of your records group by ticker, so that you understand that there will be, I will do a join first without using optimization techniques, but it depends. Since in Databricks they have a feature AQE, which helps you to optimize your join. You can see there are almost 700,000 records on APL. So what will actually happen is, let's move on. We'll go step by step to understand in detail what actually happens in a skewed join. So yeah. So what it says is a hotkey. So how can you fix that? You can use the skewed join enabled feature, or a skewed partition factor, or skewed partition threshold in bytes. So you have to individually understand these things, right? You can enable them, but again, to understand in detail, you have to see step by step. So if you do a naive tuning, right, it will fail. I'll show you why it fails, and how can we fix that? Sorting, right? So what you do is, it's like you, for example, APL has like 700,000 records, right? You randomly like distribute them into random bucket numbers, and then do a join. So that instead of joining on one giant key, you join by many smaller keys, right? And that's how you do it, right? Programmatic, yeah. So this is another example, but I'm going to use my own notebook. So you have to first detect the hotkeys and apply salt only to those hotkeys. You don't not necessarily need to apply salt to all the keys. You just have to apply the sorting technique. Sorting is basically you distribute those records under that hotkey into random buckets, right? Small number of buckets, so that when it's distributed across nodes, the join happens on that, and your job is not just waiting on one of the yeah, let's move ahead and see, now what I'm doing is I wanted to see, how it is, so it shows for both of them. So what am I gonna do now is, right, I'm gonna do an inner join. I hope you guys understand the join concept, because still, I mean, people think of joins as something very different, right? But it does have a background from sets. If you understand the concept of sets, and A union B, A intersection B, I don't wanna discuss more about that, but that is also very critical for understanding how many records are there in left set, right set, what do you want from the both the sets, what you just want from the left set and the matching from the right set, or just you just want from the left set, not from the right at all. So you gotta understand the set theories, um, because if you are really interested in data engineering, you have to understand that. Without that, you won't be able to optimize your joins. You won't be able to understand what is why the skew is happening. So these are very critical things which nobody talks about. And if you are not able to see the for example, the count of records, right? If you are not able to see this count of records while you are running your data pipelines, there is something wrong, then you haven't reached to that level of understanding why your pipeline is taking longer time, besides the features and the topics, whatever, right? So what we do is, now we are joining left with the right on the ticker column. How we are doing, we are doing on the inner join, right? Wherever so if I go to the ticker column, right, if we see what is in the ticker column, right, so I just want to see, like what is there, right? Because I like you break down things step by step instead of doing them in like that's why you have these cells, right? You go cell by cell to understand. So you can see, right, based on the matching APL, you get the trade value and event type. So let's move on. So yeah, just to check the count, right? So on the right, left and right. So what is happening, right? So what does explain does it? This is not a fixed plan. It's just a physical plan, but while running the process, it might change the plan depending on the requirements. So it's just a theoretical plan, but in execution it might vary. If there is a skew happening, it will change it at the runtime. So let's understand what's actually happening in this, because these things are very important for a data engineer to understand. It's not just SQL, writing SQL queries, you're doing group by, and if you don't understand these things, what happens first, what is the next step, it would be really hard you to optimize the data pipeline, and they will be breaking and you will be fixing issues after they like pop up, or it's up to you to determine, can you pick them earlier, like can you understand them from the adaptive, this physical plan, right? So photon result stage is just a compute stage, right? So what is actually happening is like so in this initial plan, photon result stage, photon columnar row. So basically, what happens is you actually let's understand this also in detail, right? I want to show you each step so that let's ask, can you explain this? So we understand in depth, right? So yeah. So it shows a shuffle join between two synthetic data sets, and photon is your like your cluster or compute. So it says that you have left data set to million rows, left right data set 1.2 million rows, right? Both sides create a critical column with heavy skew towards right. Then smaller spread T0 to T49, which have smaller counts, right? Both are hash partitioned by ticker into 200 partitions, right? Then Spark performs an inner shuffle join, right? So Spark builds both input data sets, shuffles both by join key, joins them, adds final projected columns, converts output if needed, return result. What is adaptive Spark plan? This means is enabled, right? If the adaptive query execution is not enabled, it will let me run this, it will show you something else, right? So adaptive query Spark plan, right? If I let us show, there is one more thing I wanted to show. What if like it is true, right? Arguments. So it's basically understanding what actually happens. So Photon this create a synthetic data set, and Spark splits it into initially 8 partitions. This is generated a random data frame, right, from storage. Now we have another one. Take a trade value distribution on the left side. 1.2 million rows, right? Rest. So AAP alone has 60% of all the rows, BTC has 15%, and remaining 25 spread across Photon, Shuffle, Exchange, Sync, right? I need the data partition by ticker before the join. Shuffle the left side into 200 shuffle partition using hash of ticker, right? So basically you redistribute your data onto 200 partitions. All the rows for the same ticker go to the same target partition. Therefore all ABL rows go to one partition, all BTC rows goes to one partition, right? Then this stage producing several files for the left side. Spark compute rows, partition them by hash ticker, right shuffle output this thing, and right side of the join. Right now you have again into 8 initial partitions, then you have APL has 700,000 rows BTC. It is again very skewed, right? So what are the steps? Actually, I want to understand. This is good. The join itself. Why shuffled hash join? Both sides were shuffled on the join key, right? Spark is using a hash join algorithm after shuffle, right? So when do you use shuffle hash join, sort merge join, or broadcast join? These are different types of join you have. One side takes rows from one side, build a hash table. Hash table is just use a hash key to put the records onto a partition, right? Probes with rows from the other side, outputs match pairs. This join can explode badly, right? Now it shows that. Because left has this, right has this, and another join means every left APL row matches every right APL row, right? So if you do a Cartesian multiplication, you have 850 billion joint rows, right? Similarly for 45. So this logically, this query is not just skewed, it is also creating a massive many-to-many join explosion, right? So what does it do is, after the join, Spark sets ticker, trade value, or constant timestamp, so it's just formatting the output columns, right? Photon works efficiently in columnar format, but some downstream consumer or funnel output path expect rows. So Spark fully supported by Photon, right? Where's the skew in this plan, right? For example, API has 1.2 million rows, BTC is 300k rows, 700k rows, or 50k rows. Has partitioning of ticker onto 200 partition. All APL rows on each side end up in the same hash partition bucket, right? They go to a single bucket. So all other tasks are completed, wherein this task take a longer time, right? So 200 partitions are not enough. So this by default we have 200 partitions, right? So but they aren't enough because one partition get all the records from APL and the other partition get BTC rows go together, right? Now the shuffling is happening between them, and then the row match pairs are being shown to us.
All
All
right.
right.
So
So
there
there
are
are
like
like,
so
so
this
this
these are
these
the
are the
things,
things,
right?
right?
Let's
Let's
see
see
forward,
forward,
right?
right?
Let's
Let's
move
move
forward.
forward.
So
So,
la-
la-
so
so
what will
what will
happen
happen
now?
now?
It
It
hasn't
hasn't
executed
executed
anything,
anything,
right?
right?
It will
It will
execute
execute
when
when
I
I
call
call
this
this
aggregation
aggregation
function
function,
john
John
df
df
dot
dot
count,
count,
and
and
you
you
can
can
see,
see,
let's
let's
see,
see,
you know,
you know,
now
now
you
you
will
will
see
see
this.
this.
The
The
tasks
tasks
are
are
actually
actually
running
running
16 by
16 by
33
33
tasks,
tasks,
and
and
you
you
can
can
see the
see the
statement
statement
started
started
at,
at,
duration,
duration,
and
and
you
you
can,
can,
the
the
way
way
to
to
understand
understand
skew
skew
and
and
everything,
everything,
right?
right?
You
You
have
have
this
the
query
query
profile,
profile,
right?
right?
So
So
you
you
see
see
everything
everything
happening in
happening in
here,
here,
right?
right?
So
So
like
like
you
you
can
can
see
see
everything in
everything in
detail.
detail.
So
So
shuffle,
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 range.
range.
So
So
if you
if you
look
look
at
at
this
this
one,
one,
right?
right?
So
So
nothing
nothing
happened
happened
when we
when we
ran the
ran the
join
join
df
df
command,
command,
but
but
when
when
we
we
ran
ran
join
join
df
df
dot
dot
count,
count,
the
the
actions are
actions are
taken
taken
then,
then,
right?
right?
So
So
shuffle is
shuffle is
happening,
happening,
right?
right?
Join
Join
df
df
dot
dot
command,
command,
inner
inner
join is
join is
happening,
happening,
then you
then
are
you are
aggregating,
aggregating,
and
and
then
then
you are,
you are,
so
so
what is
what is
happening
happening
is
is
you
you
distribute
distribute
them
them
into
into
200
200
partitions,
partitions,
you
you
select
select
from
from
left
left
data
data
frame,
frame,
right
right
data
data
frame,
frame,
and the
and the
range.
range.
Then
Then
you
you
shuffle the
shuffle the
records
records
so
so
that you
that you
can do
can
the
do the
inner
inner
join,
join,
and
and
then you
then
do
you do
the
the
aggregate,
aggregate,
and
and
then the
then the
result is
result is
displayed to
displayed to
you,
you,
right?
right?
And
And
then the
then the
result
result
query
query
state,
state,
you will
you will
see
see
that
that
this
this
will
will
take a
take a
bit
bit
of
of
time,
time,
even to
even to
run.
run.
After it
After it
has
has
run,
run,
so
so
this
this
is
is
how
how
you
you
understand,
understand.
this is
This is
very
very
crucial.
crucial.
I
I
mean,
mean,
it is
it is
very
very
important
important
whenever
whenever
you
you
run
run
join
join
records, you
records,
do
you
a
do a
left
left
join,
join,
right
right
join,
join,
inner
inner
join,
join, it
doesn't
doesn't
matter,
matter,
right?
right?
Or you
Or
are
you are
doing a
doing a
subquery,
subquery,
right?
right?
Selecting
Selecting
from a
from a
subquery.
subquery.
You
You
have to
have to
look
look
at
at
this
this
query
query
profile,
profile,
and
and
you can
you can
also
also
see the
see the
memory
memory
peak,
peak,
right?
right?
Time
Time
spent,
spent,
for
for
example,
example,
shuffle,
shuffle,
right?
right?
So
So
you
you
can
can
see
see
at
at
each
each
stage what
stage
is
what is
happening,
happening,
right?
right?
Let's
Let's
start from
start
the
from the
basic,
basic,
right?
right?
You
You
look
look
at the
at the
range.
range.
So you
So you
have
have
output,
output,
you are
you are
reading
reading
from,
from,
this is
this is
right
right
data
data
frame,
frame,
right?
right?
1.2
1.2
million
million
records.
records.
And
And
then you
then you
have
have
left
left
data
data
frame,
frame,
which
which
has
has
2
2
million
million
records,
records,
right?
right?
Um,
Um,
all
all
right, it
right.
is
It is
scanning
scanning
the
the
left
left
data
data
frame,
frame,
right
right
data
data
frame.
frame.
Now
Now
shuffling is
shuffling is
happening,
happening,
right?
right?
As you
As you
can
can
see,
see,
right?
right?
So
So
peak
peak
memory is
memory is
116
116
MB,
MB,
right?
right?
Output
Output
rows.
rows.
Now
Now
you
you
can
can
see
see
number of
number of
partitions are
partitions are
200,
200,
right?
right?
Number of
Number of
bytes
bytes
written is
written is
this,
this,
and you
and
are
you are
hashing
hashing
the
the
partitioning,
partitioning,
right?
right?
Hashing is
Hashing is
just
just
like,
like,
you
you
hash
hash
partitioning.
partitioning.
Let's
Let's
understand
understand
this
this
in
in
detail,
detail,
because
because
I
I
like
like
to
to
deep
deep
dive into
dive
the
into the
numbers
numbers
to even
to even
understand
understand
where is in where is
where is
my
my
query
query
taking a
taking a
lot of
lot of
time.
time.
So
So
you will
you will
see that
see that
it is
it is
taking a lot
taking a
of
lot of
time,
time,
right?
right?
It
It
won't be
won't be
done,
done,
but when
but
you
when
do
you
the
do the
salting,
salting,
um,
um,
it will
it
be
will be
very
very
it will
it will
take
take
very
very
less
less
time.
time.
As you
As you
can
can
see, the
see, the
main
main
time
time
taken
taken
is in
is
the
in the
shuffle.
shuffle.
So
So
you will
you will
see
see
that a
that
lot
a
of
lot of
time
time
taken is
taken
in the
is in the
shuffle,
shuffle,
and
and
then
then
on the
on
inner
the inner
join
join
part,
part,
aggregate
aggregate
is at
is
the
at the
last. Then
last, then
you
you
columnar to
columnar to
row,
row,
and then
and
you
then
have
you have
the
the
result
result
query
query
storage,
storage,
right?
right?
So
So,
and
and
so
so
optimizing
optimizing
query and
query and
pruning
pruning
files,
files,
executing,
executing,
right?
right?
I
I,
I
I,
I
I
just
just
don't
don't
want
want
to
to,
like,
like,
it's
it's
not
not
about
about
you
you
writing a
writing a
complex
complex
code,
code,
right? If
right?
you
If
don't
you don't
understand some
understand some
fundamentals,
fundamentals,
forget
forget
about
about
writing a
writing a
complex
complex
code.
code.
It's
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 not of
not of
your
your
worth,
worth,
right?
right?
I've
I've
seen a lot
seen a
of
lot of
tutorials
tutorials
on
on
data
data
engineering
engineering
wherein
wherein
they
they
don't
don't
actually
actually
explain
explain
you
you
step by
step by
step.
step.
They
They
go
go
very
very
fast,
fast
because I
because I
want to
want
see
to see
what is
what
the
is the
first thing:
first thing.
scanning
Scanning
of the
of the
left
left
data
data
frame,
frame,
right
right
data
data
frame.
frame.
Then
Then
you
you
shuffle the
shuffle the
records
records
onto the
onto the
200
200
partition,
partition,
right?
right?
Then you
Then
do
you
the
do the
inner
inner
join
join
based on
based
your
on your
hotkeys,
hotkeys,
right?
right?
Hotkeys is
Hotkeys
your
is your
ticker
ticker
column,
column,
right?
right?
Ticker will
Ticker will
have
have
APL,
APL,
BTC,
BTC,
and
and
all
all
these.
these.
Can you
Can
see
you
the
see the
number of
number of
records?
records?
172.03k
172.03K
records,
records,
1.2
1.2
million
million
records,
records,
right?
right?
And
And
now the
now the
output
output
rows are
rows are
117.78
117.78
billion
billion
rows,
rows,
right?
right?
After the
After the
inner
inner
join,
join,
because
because
it's like
it's
a
like a
many to
many to
many
many
join,
join,
right?
right?
Especially
Especially
for
for
APL
APL
and
and
so
so this
and you
and
can
you
see
can
the
see the
number of
number of
records are
records are
increasing,
increasing,
right?
right?
So
So
it will
it will
run for
run
a
for a
while.
while.
In the
In the
meantime,
meantime,
what we
what we
do
do
is
is
so
so
this is
this is
very
very
important
important
for you
for
to
you to
understand how
understand how
many
many
tasks do
tasks
you
do you
have,
have,
right?
right?
So
So
let's
let's
see
see
in
in
here,
here,
right?
right?
And
And
so
so it
that's
that's
called
called
lazy
lazy
execution,
execution,
right?
right?
So
So
now you
now
have
you
an
have an
alert,
alert,
right?
right?
Your
Your
query has
query
been
has been
running
running
for
for
over for
over for
5
5
minutes.
minutes.
So
So
I
I
know it
know
is
it
a
is a
small,
small,
but
but
it
it
doesn't
doesn't
matter,
matter,
right?
right?
The
The
you will
you will
have
have
left
left
table and
table and
right
right
table,
table,
right?
right?
One
One
table,
table,
other
other
table,
table,
and then
and
you
then
will
you
be
will be
doing
doing
join.
join.
But if you
But
don't
if you
have an
don't have an
example
example
of
of
where
where
the
the
skew
skew
happens,
happens,
now
now
what
what
does
does
it
it
say?
say?
Let's
Let's
see.
see,
It
it
says
says
your
your
query
query
will
will
be
be
cancelled
cancelled
if
if
it
it
exceeds
exceeds
the
the
interactive
interactive
serverless
serverless
execution
execution
time
time
of
of
150
150
minutes,
minutes,
right?
right?
To
To
adjust
adjust
this
this
timeout,
timeout,
you
you
can
can
like
like
because
because
it's
it's
taking a
taking a
lot
lot
of
of
time,
time,
right?
right?
Because
Because
um,
um,
it's
it's
taking a
taking a
lot
lot
of
of
compute.
compute.
It
It
increase
increase
your
your
compute
compute
cost
cost
because
because
you
you
didn't
didn't
think
think
about
about
and
and
it
it
happens
happens
in
in
production
production
or
or
enterprise
enterprise
systems
systems
where
where
you
you
have
have
like a
like a
table
table
has
has
like
like
imagine a
imagine a
table
table
has
has
10
10
million
million
records, the
records, the
other
other
table
table
has
has
2
2
million
million
records,
records,
and
and
then
then
you
you
don't
don't
think
think
about
about
skewed joins,
skew
right?
joins, right?
It
It
will
will
run,
run,
but
but
it will
it will
take a
take a
longer
longer
time.
time.
It
It
will
will
consume a
consume a
lot
lot
of
of
compute,
compute,
right?
right?
Which
Which
somehow
somehow
affects
affects
you
you
as
as
well,
well,
right?
right?
Which you
Which you
don't
don't
want
want
for
for
you
you
because
because
you have
there's
so
so
many
many
jobs
jobs
to
to
run.
run.
You
You
can't
can't
just
just
give
give
all
all
the
the
compute.
compute.
I
I
know
know
that
that
it
it
will
will
time
time
out,
out,
but
but
again,
again,
this
this
is
is
not an
not an
efficient
efficient
way
way
of
of
doing
doing
things.
things.
This
This
is
is
just
just
one
one
notebook
notebook
which I
which I
have
have
taken
taken
to
to
understand.
understand.
I'll
I'll
let
let
it
it
run
run
for a
for a
while.
while.
It
It
has
has
already
already
taken
taken
6
6
minutes
minutes
14
14
seconds,
seconds,
although
although
it
it
should
should
not
not
take
take
this
this
much
much
of
of
time.
time.
Um,
Um,
we
we
will
will
see
see
like
like
how
how
much
much
time
time
does
does
it
it
take.
take.
If
If
it
it
is
is
taking
taking
more
more
than
than
like
like
which
which
is
is
like
like
it's
it's
not
not
an
an
efficient
efficient
way.
way.
Let's
Let's
go
go
again.
again.
Now
Now
you
you
can
can
see the
see the
number
number
of
of
rows are
rows are
increasing
increasing
after
after
inner
inner
join,
join,
right?
right?
183.05
183.05
billion
billion
rows,
rows,
right?
right?
Which is
Which
a
is a
lot
lot
of
of
records.
records.
And
And
it
it
will
will
increase your
increase your
compute
compute
cost.
cost.
Although
Although
it's a
it's a
free
free
addition,
addition,
I'm
I'm
not
not
worried.
worried.
But
But
in the
in the
production
production
environment,
environment,
you
you
do
do
care
care
about
about
your
your
compute
compute
cost,
cost,
which
which
is
is
the
the
biggest
biggest
contributor
contributor
to
to
your
your
data
data
platform
platform
cost.
cost.
Uh, Storage
Storage
is
is
cheap.
cheap.
You
You
can
can
store as
store as
much as
much
you
as you
want,
want,
right?
right?
That
That
is
is
not.
not.
Reading
Reading
is
is
cheap,
cheap,
but
but
processing
processing
is
is
something
something
which
which
increase
increase
your
your
bills.
bills.
So
So
it
it
happens
happens
in
in
every
every
production
production
environment.
environment.
So
So
if I
if I
look
look
at the
at the
inner
inner
join,
joint,
right,
right,
there are
there are
already
already
201
201
billion
billion
rows
rows
as an
as an
output,
output,
right?
right?
Left
Left
key is a
key is a
sticker,
sticker,
right key
right
is
key
a
is a
sticker,
sticker,
join
join
photon
photon
broadcast
broadcast
has
has
joined,
joined,
right?
right?
Inner
Inner
join we
join
are
we are
doing.
doing.
So
So
let
let
it
it
run.
run.
And
And
in the
in the
meantime,
meantime,
what I
what I
would
would
do
do
is
is
what's
what's
shuffle,
shuffle,
what is
what is
showing,
showing,
right?
right?
Number of
Number of
partitions,
partitions,
one
one
here
here
like
like
sync
sync
number of
number of
partitions,
partitions,
then
then
reading
reading
from
from
one
one
partition,
partition,
outputting
outputting
into
into
200
200
partitions,
partitions,
right?
right?
And
And
you are
you are
doing a
doing a
hash
hash
partitioning
partitioning
strategy,
strategy,
right?
right?
This
This
is
is
there.
there.
Let's
Let's
ask
ask
ChatGPT,
ChatGPT,
how
how
can I
can I
fix
fix
the how
how
can I
can I
fix
fix
the
the
skew
skew,
skew
skew
using
using
the
the
sorting
salting
technique,
technique,
right?
right?
Sorting
Salting
technique
technique
is
is
nothing.
nothing
You
you
redistribute
redistribute
your
your
hotkey
key into smaller number of buckets so that when the join happens, it's fast. The job is not stuck on just one partition having 1.2 million records, for ticker column, right? Let's see, what does it say? Well, I'm not skipping any of those paths, right? I'm just trying to show you what actually happens. Where is the issue? Like you can see, right?
it's
It's
still
still
running.
running.
It
It
has
has
only
only
completed
completed
16
16
out of
out of
33
33
tasks.
tasks.
Let's
Let's
see,
see, you know.
So
So
split the
split the
hotkeys
hotkeys
like
like
APL
APL
and
and
BTC
BTC
into
into
multiple
multiple
sorted
sorted
versions
versions
and
and
replicate the
replicate the
matching
matching
rows
rows
on the
on the
other
other
side,
side,
right?
right?
So the
So the
join
join
still
still
works.
works.
This is
This is
useful
useful
because
because
Spark's
Spark's
built-in
built-in
skew
skew
handling
handling
can
can
mitigate
mitigate
some
some
shuffle
shuffle
joins
joins
when
when
EQ is,
EQ is,
but
but
manual
manual
sorting
sorting
is
is
still
still
the
the
right
right
move.
move.
AQ
AQ
is
is
AQE
AQE
adaptive
adaptive
query
query
execution
execution
can
can
still
still
help.
help.
But
But
again,
again,
I mean,
I mean,
if you
if you
can
can
fix
fix
things
things
on
on
your
your
own,
own,
why
why
not?
not? Like,
So
so
what you
what you
do
do
is
is
salt
salt
factor is
factor is
16,
16,
hot
hot
tickets
tickets
are
are
this,
this,
right?
right?
So
So,
and
and
let's
let's
run
run
this,
this, you know.
like
Like
I
I
look
look
less
less
for
for
code,
code,
I'll
I'll
go
go
more
more
for
for
understanding,
understanding,
so
so
that
that
somehow
somehow
helps.
helps, you know.
Let
Let
this
this
run,
run,
then
then
I
I
will
will
from
from
here
here
on I
on
will
I will
put up
put
a
up a
markdown
markdown
text which
text which
says
says
like
like
using
using
salting
salting
to
to
optimize
optimize
our
our
skew
skew
joint,
joint,
right?
right?
Like
Like
I
I
want
want
to
to
um,
um,
skew
skew
joint,
joint,
right?
right?
These are
These are
like
like
very
very
critical
critical
concept,
concept,
but
but
it is
it is
missing
missing
from
from
most of
most
the
of the
places.
places.
I
I
didn't
didn't
find a
find a
single
single
video
video
on
on
YouTube
YouTube
which
which
actually
actually
explains
explains
what
what
is
is
the
the
number
number
calculation
calculation
happening
happening
behind the
behind the
scene,
scene,
right?
right?
And
And
it's
it's
really
really
sad,
sad,
right?
right?
I
I
don't
don't
know.
know.
Like you
Like you
spend one
spend
hour
1 hour
just
just
watching a
watching a
video and
video
you
and you
don't
don't
understand what
understand
the
what
heck
the
is
heck is
happening,
happening,
with the
with the
number of
number of
records.
records.
And
And
that's the
that's the
reason
reason
they are
they are
more
more
focused
focused
on
on
writing the
writing the
syntax.
syntax.
I'm
I'm
not
not
focused on
focused on
writing the
writing the
syntax.
syntax.
Like
Like
I'm
I'm
more
more
focused
focused
on
on
understanding
understanding
the
the
things.
things.
So
So
let's
let's
not,
not,
because it's
because it's
already
already
compute is
compute is
already
already
occupied
occupied
with
with
let's
let's
stop this
stop this
because
because
it's
it's
gonna
gonna
take
take
forever,
forever,
right?
right?
It has
It has
already
already
taken how
taken how
much
much
time,
time,
like
like
let's
let's
see.
see.
It has
It has
already
already
taken
taken
11
11
minutes. It
minutes. It
shouldn't take
shouldn't
this
take
long.
this long.
Let's
Let's
interrupt
interrupt
this
this
because
because
it's
it's
consuming the
consuming the
compute for
compute
no
for no
reason,
reason,
right?
right?
So what
So
you
what
do
you do
is
is
apply the
apply the
salting,
salting,
right?
right?
And
And
see
see
the
the
magic of
magic of
salting,
salting,
right?
right?
This is
This is
done.
done.
Let's
Let's
see
see
now.
now.
You
You
have,
have,
so
so
trade
trade
salted,
salted,
right?
right?
What does
What
it
does it
say?
say?
Hot
Hot
prices,
prices,
right?
right?
So
So
what do you
what do you
do?
do?
Again, you
Again, you
create a
create a
trade
trade
salted.
salted.
Let's see.
Let's see, you know.
Is
Is
not
not
defined
defined
left
left
df, right?
df, right?
Let's
Let's
use the
use the
left
left
df,
df,
right?
right?
Like
Like
I'm
I'm
not
not
worried
worried
about
about
anything
anything
of
of
those
those
things.
things.
So
So
this is
this is
done,
done,
right?
right?
Now
Now
what we
what we
do
do
is
is
what is
what is
there?
there?
Now I
Now
have
I
a
have a
trade
trade
salted.
salted.
Yeah,
Yeah,
like
like
it will
it will
show you
show you
everything,
everything,
right?
right?
Now you
Now
can
you can
see I
see I
created
created
a
a
derived
derived
data
data
frame,
frame,
right?
right?
Now I
Now I
have
have
salted the
salted the
keys, right?
keys, right?
How have
How
I
have I
salted the
salted the
keys?
keys?
Let's
Let's
look
look
at
at
it,
it,
right?
right?
You
You
have a
have a
left
left
data
data
frame,
frame,
you
you
create a
create a
column
column
salt,
salt,
right?
right?
Where you
You
say
say
whenever
whenever
the
the
ticker
ticker
is in
is in
hot
hot
tickers,
tickers,
right?
right?
You
You
apply
apply
a
a
random
random
function
function
and
and
you
you
split
split
it,
it,
right?
right?
That's
That's
what you
what you
do,
do,
right?
right?
And
And
then
then
you
you
have a
have a
ticker
ticker
salted
salted
column,
column,
right?
right?
Salt
Salt
and
and
ticker
ticker
salted,
salted,
right?
right?
When
When
ticker
ticker
is in
is in
hot
hot
tickers,
tickers,
um,
um,
you
you
have
have
you
you
do a
do a
concat
concat
of
of
your
your
concat
concat
function
function
you
you
apply.
apply.
You
You
add
add
a
a
underscore
underscore
along
along
with
with
the
the
ticker
ticker
value
value
and
and
use the
use the
column
column
salt,
salt,
right?
right?
You
You
already
already
created the
created the
salt
salt
column,
column,
right?
right?
Um,
Um,
and
and
you
you
provide
provide
you
you
apply,
apply.
for
For
example,
example,
you
you
have
have
this
this
column
column
APL 3,
APL3,
whatever,
whatever,
and
and
then you
then you
apply
apply
this,
this,
and you
and you
can
can
also
also
see
see
this,
this,
right?
right?
Ticker
Ticker
string,
string,
trade
trade
value
value
double,
double,
even
even
time,
time,
everything,
everything,
right?
right?
So
So
you
you
can
can
also
also
ask
ask
Genie
Genie
to
to
please
please
understand,
understand,
please
please
explain
explain
what's
what's
happening
happening happening here, right?
So
So
it's
it's
not
not
like
like
you
you
need
need
explain
explain
what's
what's
happening
happening
here,
here,
right?
right?
Happening
Happening
here.
here.
Let's
Let's
see
see
what
what
does
does
TV
TV
says.
says,
You
you
know.
know.
So
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 it
it
creates
creates
let's Genie is also powered by an AI agent. So Genie is not bad, I would say. It's pretty good, you know. I'm not disappointed by Genie. So what does Genie say? This optimizing Spark joins. Left TF has 1.2 million rows, have ticker APL, right? And right has again similar 700k. When joining on the ticker column, most data concentrates on few partitions, right? Causing stragglers. Some tasks take much longer time. For skewed tickets like APL, BTC, add a random salt value 0 to 15, right? Create ticker salted by concatenating ticker plus salt, right? So 1 to 15. This splits the 1.2 million APL rows into 16 partitions with 75k each, right? That's what it is doing. Let's go ahead now. So we have seen this. Like, yeah, let's move on to the other. Because I did watch few videos on this salting, but I couldn't find the I was not happy with what they were projecting, right? So what is hot prices? Yeah, normal prices. What is hot prices? Normal prices. Replicate only hot tickers on the right side, right? Now what you do is so I have what we will do is let's change it to right DF, you know, right DF, right DF, and see right what happens. So we have now hot and normal prices. Now we can see, right? Display. Sorry, I'll just use the same one from here because I'm less worried about code you can get from, like, yeah, it's not something which someone is worried about, like price sorted. So what you do here is, let's see, price is sorted. Let's see this, what does it show, right? So now you have 1 to 15, the same one, you know, and you have done this. Now what you do next is you again do the splitting, right, based on your hot tickers in the right data frame. Yes, let's ask Genie. Can you explain the difference between difference between hot prices and normal prices, right? So let's see, what does it say? Rows from the right DF where ticker is in hot tickers, right? To duplicate across sort vector. Normal prices rows for the right DF where ticker is not in hot tickers. So let's improve this. And now what we do is we join on the salted key, right? So let's do this. This is a whole code, but I was running step by step. So I that's what I say, right? I look for the count of records. I look for trade sorted. Then you join with price sorted on ticker sorted. How in a join, you will see how fast it is. You know. Now it won't be running now. You know, it will run when you have join DF. Yeah. So it will run now as a lazy execution, right? Because of this action aggregation, like you can see now, you know. Now we will compare the query profile. We'll start showing up the query profile, right? Can you see that? You know, shuffling is happening. The number of rows have reduced, and yeah, it will be very fast as compared to it won't take a long time as compared to what it was taking when we didn't do this salting technique, right? On ticker salted and ticker salted, you are doing an inner join, right? And you have a range, right? Um, so what does it show is you have, yeah, yeah, you had 1.2 million rows, you applied the filter, you get 850k rows, then you further apply, then you get 13.6 million rows range, 1.2 filter 350k, right? And then do a native union of both of them, right? It does have a lot of records, but not like 200 billion records. It does have 20 billion something, which is because after the many to many join, it does increase the number of records and depends on the join keys as well. I just want to show you like how much time does it take. Let it run for a while. It shouldn't take a longer time. And you also look for optimizing query and pruning files, time spent improving query performance with data skipping, query compilation, and security checks. So these are the primary components which you look for while optimizing for skewed joins. I know, like I still try to explain every bit of it, which I understand is critical for the data pipelines. I've seen even the Databricks channel videos. They are good, but they are at the surface level. They actually never explain what happens in the query profile, how the records are being read, and when does the join happen, what is shuffle partitioning, how many partitions are being done. People have a lot of presentation slides. I'm not showing the presentation slides. I'm showing you the things which really work for and what you actually use while working on the production data pipelines, production grade data pipelines. The earlier job which we were doing, if we cancel this here, right? So now we have a lot of tasks, but earlier we had 33 tasks, out of which 16 were completed, right? In that 11 minutes of time. But now we have 49 tasks and 24 have been completed. Let's see, 5 are running. So rows red, bytes red. This will only be visible when you have actually completed your job, the task. So I get really, I really like the query profile, the way they show it, because it's like it helps you to debug your code as well, right? Where is the actual bottleneck? Where is the actual issue with your pipeline, right? Pipeline is like at all each step how many records you are reading or transforming. It depends on that, right? But still it has a lot of less rows as compared to what we had 200, 300 billion rows, right? Let it run for a while. It's just 3 minutes 46 seconds. It should be completed under 10 minutes. That's what I'm thinking. And yeah, so let it run for a while. Because we have done the salting part, maybe the salting of having the normal prices, but it doesn't matter, right? I'm just joining trade salted with price salted, right? I'm not joining with hot prices. Price salted is because I've kept two of these data frames, right? Which is causing it to take a longer time. Otherwise, it wouldn't have taken this much of time. If it does take a longer time, I will remove the normal prices and then see how it goes, right? But it's just a variation of things, like let us can we ask this how much time so how to choose the self you can decide how much partition you need depending on the skew factor, right? If it is a moderate skew, you just to choose 8 partitions, 16 and 32, right? This is also look like many to many join on ticker solve fixes a distribution problem, but it does not fix a logical join explosion. If you have 1.2 million rows on one side and Spark still has to produce a matching pairs. Sorting just spreads the work across more tasks. Sorting improves runtime stability, but it does not reduce the actual output cardinality. So it improves your runtime, but the actual output cardinality may be similar. Cardinality is like the number of records you get as an output, right? It's still taking a lot of time because, yeah. So what you do is, I guess, you stop this in here because I want to see. It's fine. I'll remove this normal thingo from in here. So price sorted is equal to hot prices dot copy, right? I'll just I just want to remove this normal prices because it's taking a longer time, right? I don't want to spend my time on doing this. So can I just because hot prices, right? Let's go back again. So you run this command join df again. Yep. And now you run this again and see how fast it is. How does it improve? Yeah. You can see that because of the union of that normal prices frame, if we do separately, then it will take less time. But if you have like, because all you can check is the number of count of records, right, in the overall hot prices data frame. If it is a lot of records, again, it's going to take a longer time. Let's see how much time does this take. So now what is happening is, definitely the number of records are reduced. We are not scanning all the records, which is good. If you do not need to scan, right, range, filter, generate, range is 2 million because there are still a lot of records. Filter, then you have generate 1.52, then you have inner join. Yeah. So let it run for a while. This time I'll let it complete, even if it takes it like whatever time does it take. So let's ask, if I just have hot prices in hot prices in the prices sorted, and do an inner join, with trade sorted, right? That's what it's a derived data frame, doesn't matter, right? So I don't care about the names, I just care about trade sorted. How much time will it take, will it take no. Predict the exact runtime, but in your example, it would still likely be very heavy because the real cost is the hotkey join output size, not just the number of rows on the right. All normal tickets, yeah, the output is still enormous, right? Important time solving does not reduce that 85 million logical matches. It only spreads the work across more partitions. Faster than joining with the full prices. Yes, probably somewhat faster because you are removing normal ticker matches. Right side is smaller, less shuffle for non-hotkeys. So that's what I thought of, right? Faster than full join, yes. Fast overall, yes. Not necessarily. So you can compare your pipeline performance, right? It will improve, right? The number of tasks have reduced. Let it run for a while. And for now, what I would do is, I'll pause the video for a while. So let's go back. As you can see, this job has been completed within 6 minutes 43 seconds, right? So that's the difference, right? Let's see another version of it wherein I had this. So what was the issue, right? We had Both, right? So we had both the columns, right? I want to see that scenario wherein I have how long does it take, right, to run with, yeah. So what you do is left, right, df, because it's all based on the number of records being read and the join happening on them, so, and the earlier process couldn't complete even in 12 minutes, right? So let's run this again. Now what I would do is I would put them separately at the end so that I can see the timer of it. Let's run this. You can see, right? And then you have a join which happens, So this is without, this is along with the normal prices. And then you run this again. What is this? Join df2. Just let's see again df2, right? What is the issue, right? So let's see, I can include the code, columns exist. So now what I will do is I will just run this to see how long does this take now. It took almost as you can see the performance, right? It took 6 minutes 43 seconds without the normal prices because I excluded it. I wanted to see the performance. How does it work, I've named it as a join df2, so these are two different data frames now. It's just to show that how the performance of the pipeline improves with the changes you make at each step. So it's like a step-by-step performance of the pipeline. It isn't just about writing a SQL code. It's much more than that. That people don't realize. Yeah, let it run for a while, and yes, I will. So as you can see, I reran the task by changing the data frame wherein I included this normal prices, wherein, as I explained, right, when you have hot tickers, right, there is normal tickers, and then I did a join with the trade salted, which is the derived data frame. And then when I look at the performance, this one took 31 minutes 36 seconds. That includes both the data frames, right? The one with the normal prices, the one with the hot prices. But if I see the first one wherein there was a skew without salting, right, it would go on for about 50 minutes. And I don't know, like it may take a longer time. So I hope I was able to explain salting in a bit detail. I hope this helps in understanding how the salting works. What does salting actually mean? How can you use salting to optimize your data pipeline? And today's video was just focused on optimizing the Spark Shuffle and Join. I haven't. It's basically taking two random data frames and then working on them. If you really like what I do, please consider liking my video and subscribing to my channel.
so that I'm able to share more knowledge and what I know of from a data engineering perspective. And yeah, it's like I want to share as much as I can, and the amount of understanding I have of data engineering, being a data engineer. Um, and also, I this was one of the pain points which data engineers usually face while running data pipelines or your jobs in an production environment. And with this, I would like to end this video. I hope I'm able to help people understand Spark Shuffle, as well as how we can see the query profile, as well as optimize the data pipeline. Thank you.